Hi and welcome. I'm trying to learn archaeology. Today, archaeology. While doing ECU tendon training. The ECU tendon is here. And if you participate in the ECU tendon training in the second half of the video, that is at your own risk. I found archaeology. That is part 2 already to the archaeology part of archaeology. And we already know that archaeologists, these are people looking for relics of humans or the temples or the houses, and to try to find out how they lived. And many of these relics are under the ground, or at the sea, or in the sea even, lying beneath the sea. And they're using aerial photographs. They're going with planes over the earth and looking where maybe the plants are growing a bit different, and then that gives maybe an idea that at that place there might be something underneath a wall which makes the grass growing differently on top. We're using also metal detectors and other electronic probes to pick up features on the ground. So we're sending out signals, the electronic, and if it goes through soil, it just passes through and is away. It comes against the wall, it comes back like a football against a piece of earth or sand. It doesn't bounce on sand, but against the wall, it just comes back to football. And so also these signals, the electro signals going back, and now people know there's not just soil, there's something else. And now we're digging it up. And maybe it's an old temple. Field walking, yes, we're going through fields and trying to find something lying around. And during a dig, archaeologists dig carefully down through the layers. They note exactly where every relic was found in case its position helps to reveal the soil behind the site. Yes, they're making it all carefully. They're taking all the time pictures and we're writing exactly down we find here at that place. They take the whole thing. I think they're doing it that way. And they're writing them down, with taking every little inch on the thing and saying what is. We're making it like a rest. We're going to say 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, and when we're finding something here, we can count. I'm 4 meters from the left corner and 2 meters in from the top, and we're writing down 4, 2, and now every person, even 100 years later, knows at 4, 2 they found that piece of table, yes, of what is it called? It is a plate of plate. And now that gives them maybe some idea of what was where in the house which we found. Fine. Archaeologists have found many remains of Roman life. Roman pottery was beautifully made and designed, while statues give an idea of how Romans looked, or clothes were. Oil-burning lamps have been unearthed, and we know that the Romans loved beautiful jewelry. Okay, here are some examples of things which were found from the Roman times, so around 2000 years ago. We've found here pottery, so vases and statues. Here's the head of a statue, and we can see how the hairs were, for example, and lamps. They're burning it, there's oil, and then there at the top there's a little flame and a lamp, and jewelry, necklaces. Archaeologists have found many remains of Roman life. From the Roman times, many things were found. Archaeologists call on many different kinds of experts to help them to interpret things. Forensic scientists may help to tell how a skeleton died, for instance. Now we're coming forensic scientists, and maybe we find a skeleton. Now we're going to look there in that skull which we found. There's a big hole, and now we're looking very carefully. We're making studies. We're looking very carefully. We're examining it, assessing it, and then we're going to say, based on their experience and what we learned as forensic scientists, was the skull just lying there for 2000 years and a tree has fallen onto it, or was it a crime or from a battle? And that helps them to tell the people also a story. If they are at some place are lying a bunch of skeletons are found, and they're finding then also armor and swords which are not completely rotten away and other things, when we slowly getting idea, here might have been a battle. And we're also looking then in text and looking, has someone written somewhere, here at that place there was a battle, and now we're looking and we're saying we find here in that area, we're finding all these armors and these old swords, these spears, and also we're finding bones who had all these marks of this battle in there. I'm going to talk a bit about war. And they're having all these marks of war. And we're going to say at that place there was that battle, and when they are digging further and they're searching and they're looking, and then they're finding more out about what happened there at political things, how many people actually fought here, how many died here, and how did the battles look like, and then we're getting a better understanding of how the people lived then and how battles were fought, what war they led, so we learn from them and don't do the same thing as they did. So that we have an example how not to do it, basically, from these things. And the deeper a relic is buried, the older it is likely to be. Now, is there something that's lying on the ground, leaves are falling into it, dust is coming onto it, and over the time, more and more things coming onto it. And now, and the deeper something is down, the older it is in general. Radiocarbon dating is a way of dating the remains of once living things from their carbon content. This is accurate up to 50,000 years ago. Now, I heard someone talking about it. Once living things, I mean plants. Now, a person was explaining that when a plant is growing, it is taking through photosynthesis, for example, it is taking the things from the sun. And now it puts them into its cells. So the plant puts them into the cell. And as soon as the plant then is cut down, the plant isn't getting any more new things from the sun to build it into its organism. So it's at that place stopped where the plant is cut. And there are plants out of which wool is done. That's not wool, but the other thing, the cloth. And now if you find a piece of cloth made out of something which can be made yarn out of, that yarn, which was a plant, had stopped to take these radio emissions from the sun into its cells at the moment when it was cut. And these with carbon in it, through the sun built in, I don't know exactly, does go away over the time. It doesn't stay there forever. It goes away like water. If you have something lying around, you can take actually a plant and let a plant lying there. Take a fruit with you. Look like it's just it's laundry. If you just let it hang there after a couple of hours, it will get dry. And so basically the carbon in it over years goes away. But it's very slowly, and always, I think it's always for half. I think it works for carbon also that way. And now we can look how many is still left of that, and I think it goes into another process. It does not go just away, but into another form of carbon. Whatever. Somehow it looks then differently. And if we can go there and we look, that is carbon which has fallen into two pieces 10 times, whatever. Or it is carbon and so much carbon is left. I don't know how it exactly works. We're just looking at it and looking how much carbon is still in there. And when we're going to say, because we know that carbon does go to the half every 200 years, I have no idea, every 200 years, we can say that has fallen apart 10 times with carbon in it. These were 2 pieces, 4 pieces, 8 pieces, 16 pieces, I have no idea how it actually works. But just so you have an idea. Now we're going to look, this carbon in that cloth which we found has fallen apart 16 times. And now we know it falls every 200 years apart, so that thing is 3,200 years old. If you find in a piece of cloth carbon which has fallen apart 32 times, I don't know exactly if it's fallen apart or whatever happens to it, then we could say that we know that carbon falls apart every 200 years. When we know this thing had 16 times fallen apart every 200 years, this thing is 3,200 years old. And we can do it pretty exactly. Now they're writing here, this method is accurate up to 50,000 years ago. So they can take ice which is 40,000 years ago and can date them back when this ice was frozen. Or other things which are 40,000 years old, rocks probably, no, living things, rocks not. Ice, but inside of the ice could be something. But they can find plants which are maybe 40,000 years. I don't know what we're doing now with 50,000 years. Now, something else interesting thing that I heard them saying, that this radiocarbon emission has a little problem that the humans were making these nuclear bombs in the last century, and that these nuclear bombs, that they were exploded on the human Earth, emitted way more much radio emission into the atmosphere than the sun is doing. And now every plant and everywhere has way too much in it. And now it doesn't work for plants which are growing today. But it still works for older plants, but not for plants which are growing today. Did I heard say, I don't know if there was maybe an exception or better methods to find it out. But just radiocarbon method, the carbon in it is measured, and a specific number of after a specific time it gets less or it's halves or whatever. And now we can look how many times it halves or how much is there, and we can calculate back. So that is phase 16. These are now 32 of them, so it means it has split it literally just 5 times, I think. 1, 2, 4, 8, 16. We have 6 times, so 6 times 200 years, 800 years. Whatever, that is the radiocarbon method, and the people are coming there and looking if they find a piece of cloth. How many times that carbon in it had split it. We want to do ECU tendon. We're going to do a third part to archaeologists of archaeology. If you're here for archaeology, you can go directly to the next part. We're going to do now the ECU tendon training. If you participate in the ECU tendon training, better set your arm desk. We're doing the floodgate. The arms next to us, and we bring the fists down and holding that. Up and holding that. Again, down and holding that. And again up. And the last time down. And next exercise. Now fist next to us, and we bring them to the inside, holding it. So you outside and holding it now, and the 3 rules. The first rule is again inside. And we're stopping immediately as soon as there's pain. Be outside. The second rule is that we're going only as far as we can go with a little bit of effort to the inside. And to the outside the last time. And the third rule is that we're not overdoing it. We just want to strengthen, not to exhaust. And next exercise, I'm using a tennis racket for the next 2 exercises. You can use also dumbbell, but do it in accordance with our 3 rules. The tennis racket is light, but it has a long lever. We are having a long arm out, and we're bringing the racket slowly to the outside. And back in. And to the outside slowly. So our 3 rules: stop immediately as soon as there's pain. Go only as far as you can go with a little bit of effort. The next 4 exercises actually. And inside. Don't overdo it. You just want to strengthen, not to exhaust. And the last side of the inside. Yeah. Now with the small arm, take the lower arm, go slowly to the outside. Back into the middle. To the outside. And the last time. And now with the other arm, slowly to the outside. To the inside. And now with long arm, slowly to the outside. And the last time. Now take the racket from the top and bring it up, and over, back in, down. Take the racket, palm facing upwards, hand up, and over, back over, and in. Now take the racket from the top again, the other arm up, over, back in, and down. And now again palm facing upwards, up, over, back in. We skip one. Wherever we're doing the last exercise, take a sock, a towel, whatever, and press with good force onto it. With the other hand. And thank you very much, and